All right, we are simplifying radicals. A radical is an expression that has a square root symbol in it or other root. So if I have radical 25, what that means is please find me a number that you can multiply by itself to get 25. And that, of course, is 5. And you know the square root of 81. 9 times 9 is 81. So that's a number that can multiply by itself to get 81. So that's 9. In case you're worried about it, only 5 is the square root of 25, not negative 5. When you see the square root symbol, it implies that's the positive square root. So what we mean by simplifying, though, is this. What if you end up with square root 40? Well, there isn't a nice whole number that squares to get 40. 6 squared is 36. 7 squared is 49. We missed it. It's between 6 and 7 somewhere. And so rather than writing a decimal and trying to figure out how many decimals to round it to, what we're asked to do is simply write it in simplified form. And if simplified form means there's no perfect squares underneath the radical sign, what that means is this. We know that square root 40 could be written as square root 4 times square root 10. Okay, well, square root 4, that's just 2. So there's a perfect square under the square root sign. We don't want that, so we're splitting this up and writing it as 2 root 10. So there's two methods for doing this. One you just saw, we'll do a few more of them, where you find the largest perfect square factor of whatever number's underneath the square root sign. So if I was asked to find the square root of 20, I'd say, well, what's the largest perfect square that's a factor of 20? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So if I just look at those, 1 is a factor, but that's not really going to help much. 4 is a factor of 20. 9 is not a factor of 20. 16 is not a factor of 20. The next one's 25, and that's over 20. So I think we can be done. So we're going to say the biggest perfect square factor of 20 is 4. So we're going to write square root 4 times square root, let's see, what would we need to multiply 4 by to get 20? 5. Okay, and then we simplify square root 4 down to 2 and leave the square root 5 by itself, and now you've simplified square root 20 down to 2 square root 5. So what if we're asked to square root 72? Okay, there's no whole number that works. So using this find the largest perfect square factor, we're going to say, well, 4 goes into 72, and 9 goes into 72. 16 doesn't. 25 doesn't. Does 36 go into 72? Well, yeah, it does. It goes in twice. So we're looking for the largest perfect square factor. So we're going to say square root 36, and then what's left over? Square root 2. Okay, and now square root 36 is 6, and so you get square root 2. Okay, so that works. Okay, I prefer the prime factorization method. I'll show you why in just a second. Here's what it means. Let's say we're going to find square root 20, and so I know that 20 could be written out as 2 times 2 times 5. And these numbers are important, that I'm only using prime numbers. Okay, so 2 times 2 times 5, those are all prime. If you multiply them together, you get 20. Well, here's what we're going to think about. This square root, let me show you, this 2 times 2 could be written by itself as 2 times 2 under the square root times square root 5. And look at that. 2 times 2 is 4. Square root of 4 is 2. So we end up with 2 square root 5, like we did before. Okay, 72, its prime factorization. Let me 72 could be written as 2 times 2 times 2 times 3 times 3. And we'll just a second, we'll get to how we can generate this list. So here's what I'm looking at. Here's a pair of 2's, right? Okay, that square root 2 times 2 could be written separately. Here's a square root 2 that's by itself, and here's a pair of threes. Okay, so I'm going to look at this and say that is going to simplify down to 2. This is going to stay by itself, square root 2, and this last part is going to simplify down to 3 because 3 times 3 is 9. Square root of 9 is, oops, I shouldn't have drawn that. Okay. That's going to simplify down to 3. So our result ends up, we'll just take the 2 times 3 and multiply them together and get 6 square root 2. So the question comes up, though, how did you generate this list of numbers? And here's 2 methods to do them. I like the ladder method, but I'll show you the tree method. Take 72 and ask yourself, what 2 numbers might multiply together to get 72? And it doesn't really matter which pair you use. I'm going to use 8 and 9. Okay. Can you think of 2 numbers that multiply together to get 8? Well, yeah, 2 and 4. Okay. Can you think of any numbers that multiply together to get 9? Well, 3 and 3. Okay. 2 is prime. The 3's are prime, but 4 is not prime. It can be split up into 2 and 2. So when you get to the bottom, the parts at the very end of the tree are your prime factors. 2, 2, 2, 3, 3, just like we had before. Okay. I tend to prefer another method that works for me. It's more comfortable. I do this. I say, suppose you want me to find the square root of 200. Okay, so I take 200 and I start dividing it by prime numbers. Okay, here's a list of prime numbers here. 1, no, one's not prime, excuse me. 2, 3, 5, 7, 11, 13. They go on forever, but I usually find it up to 13 is about the maximum I need. So I'm going to take this 200, I'm going to start dividing by the lowest prime number I can. And I put my divide sign upside down just so I can go down the paper instead of up. I'm going to divide by 2 and get 100. Now 100 is not prime. Can it be divided by 2 again? Yes, it can. Okay, and what do you get? 50. Well, can 50 be divided by 2? Yeah, you get 25. Can 25 be divided by 2? No. So go down, can it be divided by 3? Well, no. Can it be divided by 5? Yeah. And what do you get? 5. 5's prime, so now we're done. So here's the way I like to look at it. Here's my list all in a row, real nice. Okay, where this one is a little hard to keep track of which numbers are at the very bottom and getting them all set up so you can say, well, here's a pair of 3's. I'm sorry, a pair of 2's, and here's a pair of 3's. So I'm going to get 6, and I'm going to leave that extra 2 back inside the square root sign. With this, it's really easy because I just have them all in a row. I've got a pair of 2's and a pair of 5's. What that means is I'm going to have a 2 and a 5 outside the square root sign and a 2 inside. So the answer is 10 root 2. So if I'm looking at another one here and you ask me, please find the square root of 180. Okay, I like to use the ladder method, so I'm going to say 180. It divides by 2, I get 90. It divides by 2 again, I get 45. That doesn't divide by 2, but does it divide by 3? Yeah, you get 15. Does that divide by 3? Yes, you get 5. 5's prime, so I'm done. So here's my pair of 2's. Here's a pair of 3's. That means I'm going to have a 2 and a 3 outside and a 5 back inside the square root sign. So I end up with 6 square root 5. Okay. Now there is something I do want you to see here, and that's this. If you end up with a really big awful number like this, 2 times 3 times 3 times 5 times 7 times 7. I don't even know what number that would be. But I'd be saying, well, here's a pair of 3's, here's a pair of 7's. So I'm going to have a 3 and a 7 outside the square root sign. That's going to be 21. And then inside, I still have 2 times 5, so I'm going to remultiply those together and get 10. So if you have more than one number still left on the inside, just multiply them back together. Okay, so that's a rough picture of how to simplify radicals.